Hello, geometry, and welcome to our Monday lesson for 10.6 circles and arcs. Bam, 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 bam. Okay, this is pretty simple. Probably a lot of stuff you've already learned. We're going to learn what minor arcs are. Minor arcs. This is your homework page, by the way. And major arcs. And what semicircles are, but I think you already know what semicircles are. We're also going to learn how to find measures of arcs, measures, and naming, of course, too, which is good. We're also going to be able to find measures of arcs inside. Our lesson for Wednesday will be how to find circumference and actual distances of arcs partially around the circle, which is cool. So you know, if you have a circle, there's lots of things we know already. Like this guy right here is called that's right, it's called the radius. Nice job, kids. This guy all the way across is called the diameter. It's actually the largest chord in a circle. We'll learn about chords next week. So this is called the diameter, as you know, but of course we already know that 2 radius is the diameter. We'll use that on Wednesday. Now, what we're going to be talking a lot about is, this angle inside right here. This is actually called a central angle because that is the center. In fact, if I was to call this like circle A or something like that, you could even go like, hey, look, this is circle A and notate it like that. But this is central angle A. Heck, we could even call it BCD. This is central angle BAC. And of course, it's a central angle because the angle's inside. Next week, we're going to talk about angles that are inside and onside and crossing and all that kind of stuff. Now, here's the deal for today. What we're going to be doing first is called minor arcs and major arcs. Now, minor arcs are just the portions that go around the circle. These are all arcs of a circle, which I think we know that word already. So a minor arc is actually an arc that is less than 180 degrees. So I'm just going to put a few letters around here. We're going to call this circle O, which is kind of fun. There's A, there's B. I'm gonna make a diameter right through here. We're going to call this C, and then we're going to put a D way over here. So a minor arc is an arc that actually is smaller than 180, so an arc like AB. And if all we need to do is find an arc that's less than 180, we're going to say, oh, AB. But the cool thing about this is we call it AB like that, but then we put a cute little arc mark over it just like that. I got another minor arc, BC. There's another one, AD, and another one, DC. I guess I should put those as well. You can go either direction. You can go AD or DA. You can go CD or DC. Now, a major arc is an arc that's bigger than 180. And, of course, it's less than 360 as well. So all of my major arcs, it's like, oh, well, I'm wondering. Well, let me go back for a second. So let's say I was looking for something like, what are the minor arcs on here? All the ones that are smaller than 180. Now, so you just look for the ones that are smaller than 180. Major arcs bigger than 180. So something like, oh, now this is kind of cool because if you did D to A to B, I don't know, but A to B to C to D, that'd be bigger than 180. But you can't use 4 letters, but you can use 3, which is super cool. So we're going to be able to actually call an arc by 3 letters. So I'm going to go ABD. Now watch this. If I had ABD, that would be the arc. And these are the arcs we're talking about. Like there's arc AB, that chunk of the circle. Arc BC, chunk of the circle. So if I went arc ABD, it would go through A, through B, all the way around to D. It sort of gives you the direction of which way to go, ABD. Of course, I could have called that same arc ACD, but similarly, something like ACB would be the other one that goes all the way around. Really, arc of the circle that's bigger than 180, bigger than diameter, and smaller than the whole circle. And semicircular arc is really with this one, if I'm calling this the diameter. Of course, we know it's the diameter because it's going through the center. I'm just going to call it AC or well, I guess I can say you could go AC the other way, but it's the same one. So AC is the semicircle. Now, there could have been more up here. So I could have said more, whatever. If they just say, hey, name one, then there we go. Now, what they're going to do now is ask you how big central angles are. And since we know that a full circle is 360, there's lots of different things we could do. So I'm going to do an example from another page that will help us learn this one right here. And I'm going to zoom in just a little bit here to our picture. It's going to be great. Okay, so if you can see this picture right here, it says, hey, how big, sorry, not the greatest technology. It's saying, hey, how big are these different angles? This is a good example one right here just to look at. And you can reference this one again if you want to, which is good. So it's just going to say like, hey, look at this picture right here. Consider the image. There's a 90. There's a 151. And since the diameter goes all the way across, we also know that's going to be 90. But I'm going to start looking here. Oh, look, well, that's going to be 180. Of course, we call that a supplementary linear pair. But we know that 151 from 180 is 29 degrees. So that's kind of cool, that little central angle at the center of the circle, central angle. So then it just says, well, I don't know what this is. Is this an angle? Is it whatever it is? And the cool thing about this is, as I'm going to show you here, we actually, arcs and angles in the center have the same measure, as we'll learn again on Wednesday. Let's say this is like 80 degrees right here, this angle. Well, if that's 80 degrees, then we actually say that this arc is 80 degrees of the whole thing. We would actually say the measure of arc DC is 80 degrees because that's 80 of the 360, which is kind of cool. It's the exact same thing. This is 180, arc AC is 180. This arc right here is 100, arc AD would be 100. So whenever they give you anything, I'll just do a couple of these for example. They say, hey, what is the measure of arc GJ? Well, you go over here.